This conference will now be recorded.
Okay. So I wanted to first summarize quickly the discussion we had last time, so that we hopefully move forward rather than repeating what we talked about. So we've been kind of like going back and forth on what to do, but I think towards the end of the meeting we had, I would say, some good clarity, which was that in principle we had a couple of options to work on that we afterwards realized that they're all important, and it's really just a question of like sequence of how we attack, like or attack them. So
And maybe,
yes.
so are you sharing your screen?
Not yet, but I can do that. I have some notes on here.
Oh, okay, I thought you share when you share your screen.
No, that's good. Yeah, no,
Yeah.
it may be easier for people to also
We
see.
can.
Thank you
Yeah,
for
especially
reminding me
yeah,
there.
or new people. I think
So
joining. Yeah.
yeah, so the options that we talked about last time, just as things that are all of value, and I think different people had different priorities, I would say, was to talk through the existing platforms and understand the time to market and cost benefits of using either the SmartNIC platform or the platform that was presented from Samsung and Fraunhofer, and compare that to a monolithic design. That would be one. The next step would then be to talk about, like, to make a basically assemble information of things that help you decide if you want to use chiplet for a vertical integration use case, what you have to consider for chiplets versus using a monolithic design. And then the third step, and that is even more broad and even more challenging, is trying to address some of the challenges of this open chiplet market and the dynamics around it, and trying to help navigate this or finding solutions for it. But so we decided, at least at the end of last meeting, that we're going to stay very close to the things that we have, which are the presentations from Suresh and from Kevin last week about the platforms that these people are already working on. And then Bapi, I actually went back in the recording to write this down again because you phrased it so well. The question is specifically now, what is the time to market and cost advantage or disadvantage of building an accelerator and plugging it into one of these platforms versus building an entire SoC with a comparable function? So I was hoping that we could basically use that as a starting point for today's discussion. Does that sound good?
So you want to talk only about cost advantages, not about advantages in general? Or do you want to talk about advantages in general?
I think in more, so I think this would be, we would look at so we have these platforms, and a new company coming in would now have to decide, should I go with that platform, or should I develop my own monolithic system on chip? And any like advantage or disadvantage going either way, I think we should consider, because ultimately that is going to be part of the decision.
Yeah, may I share my screen very shortly?
Sure, yeah. Let me make you a presenter.
I think that.
Oh, you can already do it. Perfect. Yeah. Okay.
Yeah. So you remember the last time I said I will be, like gathering some examples of current chiplet usage. I've done this. I've seen that you have enhanced the table, but I did not have a chance to go through that. This. However, even with the information which I have gathered, I think that you have some, indications why people are using chiplets in general. So there are two companies who use chiplets for a long time and also push usage of chiplets, also in an open source context. This is AMD and Intel. And Intel, their motivation is flexibility, cost savings, and easy scalability. So they're using chiplets since 2015, and they have already successfully reused chiplets in their system. So the motivation which they have been having is that the manufacturing complexity is smaller, and then you also save about, so this is the AMD estimation, about 40% of the cost.
Are you
And
sharing something? Because
yes, I'm sharing. Is it
am I
not
the only one
visible?
who can't see it?
I can see
I
it.
can see it somehow. That's strange.
You can see it?
Okay. Okay. Maybe I should log off and call in again.
Somebody might be
Yeah.
Let me
hiding.
try that.
Maybe
Wait, I
hidden.
can't see it either.
You
Oh,
can't
okay.
see
So
it
maybe
either?
then let me
Oh.
try again and
No,
Sure.
maybe I just log off and try again. I don't know.
No, let me also stop sharing and then I will share again because I actually shared before Marek told me that he gave me the right access rights.
no. I the only option I see here is to make you an organizer, but I think you should be able to share on your own.
Oh,
Okay.
not much better. I can see it now.
You can see
Okay.
it now? Okay.
Yes.
Awesome. Yeah, you're welcome. Okay, so coming back to the discussion, this table, which Marek has also provided online, which I have created, but Marek provided online, it contains AMD and Intel. And for AMD, it is stated that AMD is using chiplets because it offers flexibility, cost savings, and easy scalability. And those sentences are basically citations from the article, which you find to the right. Chiplets require less materials and manufacturing complexity because they are smaller and cost 40% less to produce from raw materials. And I've been trying to dig into this a little bit yesterday. I think that the reason why they are cheaper is that you can use a smaller piece of silicon to produce chiplets, so you do not require a large piece of silicon to produce chiplets. Chiplets also dramatically reduce energy requirements. Chiplets require less materials and manufacturing complexity. Okay, I think with manufacturing complexity, this is a no-brainer because, of course, to produce smaller chiplets, you require less manufacturing complexity. So some of the things I cannot fully explain to myself, but maybe we can have a discussion on those. Then coming to,
could I just go in there? Like, so one thing, so this is like helpful table, and I added basically some examples there to just from the kind of memory where I know there were articles about companies using chiplets. One thing that we discussed last week was to say that, and this is kind of what I touched upon initially, that we have these two use cases: the companies using it internally for their product strategy, and then the kind of the next level up is basically having platforms for other people to participate, for various like different companies to build a platform. And we kind of so having this information, like I think everyone is aware that AMD and Intel are doing this because it helps them save money or gain performance. Like there is, otherwise they wouldn't have gone so far that they have. And so we wanted to not spend as much time on that discussion because it's basically more of a recap of what we know empirically already works. And there are papers and everything on that, but rather try to focus on the question of these platforms where basically different people can contribute chiplets and build something together, because that hasn't caught on widespread, like in a widespread way so far. And we want to understand better, if somebody were to take that decision, contribute to some platform versus do their own thing, what kind of decisions do they have to face? Does that make sense?
I think we should do it in the second step, because in the first step, first of all, I think your question was, why should somebody use chiplets? And I think we have not answered this question yet. So as soon as we're able to clearly answer the question, why, when I, like decide to start a product, why I should use chiplets, we can switch to the second topic. So if the first topic is clear to everything, then I can stop here and we can switch to the second topic.
I think most people have a good understanding of why chiplets are like very interesting in certain regards. So yeah, I think that to me this is more kind of a reference document, but I think we can go already to the next step and specifically now think about this open market case, or let's say like partnership case.
Okay, everybody agrees?
Yes, I agree with Marek.
Okay, then we can go to the second step.
Okay. So I can share my screen again. Like, so the there would be similar, I guess, questions to answer. And for me, for the group, I've been thinking a little bit about what the basic questions would be to cover to answer this specific question. And I am not seeing Suresh on the line today. My personal, I guess, take is that it does require a certain amount of information about the specific system that you're trying to build and that you're comparing to. So since we as a group kind of discussed that as our first step, I wonder, like, what do other people think of how can we go about answering this question with, like, let's say data or at least something specific rather than just saying it looks good and that's why you should go with it.
Marek, actually, I'm a little bit confused because we have this option summarize A. So I was actually answering the first point A, talk about existing platforms, what TTM and cost benefits against monolithic design. So the table is basically answering this question. So should we then summarize the answer from the table I have been showing
also by platforms, we've I'm not sure if you've been able to join the general ODSA meetings. There have been 2 presentations over the last, I guess, 2 weeks or 3 weeks. One was from Samsung and Fraunhofer, where they talked about building a platform that they want to open up to partners so that you can use a chiplet from somebody else. And then there was also the presentation from Suresh talking about this SmartNIC platform, where again the goal is that they offer one chiplet and you can design to use their chiplet and add your own parts. All the things that you've been showing and other examples that I'm aware of are all like individual companies, and right now you're not able to go to AMD and say, can you please sell me your compute core complex and I want to build a different IO hub. It's just not part of their business model right now. And so that's why by saying platform, I mean something where you can actually get access to a chiplet and plug your own chiplet into it.
Okay, yeah, sounds good.
So, Papi, since you have proposed this, do you have like any ideas that don't get us into a question of like what is the, like, how much did you spend developing it? How much is, like, basically the thing that a regular company, I assume, would do in terms of like back of the envelope type math?
Well, wait, say your question again. Maybe I'm
so basically, since you had, I remember last time you said this is an easy question to answer, and if it's so easy, I'm just curious about how you would go about answering it, hopefully not getting into the kinds of details that you can only get when you actually have an NDA and look at the cost model and so on.
Yeah, just to be clear, at least I'm not sure what I said, but what I intended was that it's an easy question. It's easily the question we ought to answer more than whether it's easy to answer or not.
Okay.
But, okay. So in my head, what you have so at least the way I was breaking it down in my head was you have your choice of two development approaches: buying soft IP and building a complete ASIC and building the software for that ASIC, versus building just the accelerator portion, attaching it to a hub, and within some constraints, within whatever constraints the hub supports, and getting a product and building a packaged product with that, your chiplet and other chiplets.
Right.
And so in my head, I was trying to I figured we could compare the total development time, the total development cost, the unit cost, and the unit cost, manufacturing cost, and compare it for markets of different sizes. I think it's a no-brainer that it's of an ultra large market. Developing your own custom chiplets, entire set is going to win.
Right.
It is this notion of a high mix, low or medium volume market where this should play out. Can you get to market more quickly with this than in developing your own chip, and can it be a meaningful amount of time?
Yeah.
that to me was like, can you make the case? And then Suresh keeps pounding away, but he's not here, is he?
He's not on today.
He's not on. Okay. Let me see. He keeps saying cost shouldn't be a metric. Manufacturing cost shouldn't be a metric. It's more that you're going to you have the ability to experiment in a way that you wouldn't with
Okay.
if you had to develop your own product. I'm not 100% sold on that.
Yes, I think at least being in the business group, I don't think you could say cost doesn't matter, because that is basically half of the whole consideration.
Well, yes
No.
and no, right? I mean, he's got a point in the sense that if you can capture a market by being one year ahead, then and you're solving an important problem, then people are going to be willing to pay up.
Right.
Right. At some point, if you can truly show a huge increase in development time, or decrease, excuse me, it's not a completely irrational claim, I guess, is what I would say.
Okay. Anu, you were going to jump in?
Yeah, so, in a sense, I understand what Suresh is saying, right? So if you, for those people in the world who aren't going to build die that are reticle area, the cost of manufacturing triplets is always going to be more. And I'm not talking just silicon cost, right? I'm talking about unit cost. So when most companies look at unit cost, you're looking at cost of goods, which is the silicon cost and the assembly cost and the yields associated, your yielded cost of all of those together. It's going to be hard to come out on top of a monolithic in that case,
Right.
unless you're doing what AMD is doing or Intel is doing. So in a sense, I support what Suresh is saying, where if you focus on unit cost, you're never going to do chiplets, because that's the only number that strikes you. But if you are a year and a half early to market, now we're talking, right? Now you've captured a market, and how do you put that on? How do you account for that advantage?
So
Yeah,
I don't know if I'm making sense.
AMD is studying something else, because they say that they come to a much cheaper solution through economies of scale, because they, if you produce like a one die SoC, then you have your specific logic for every SoC. If you use chiplets, you can produce, I don't know, 10 billion chiplets, and then use it for basically every product, and use them for every product which you produce.
So I think
right. So the IP reuse point of view, right?
Yeah, so they say that they do not need so many variants, and therefore they can be cheaper through economies of scale.
Correct. So that is the idea of a company shifting its product roadmap to chiplets, right? There are three different business issues as I understood them. One is, if I want to build really large products, a chiplet-based product is a far lower manufacturing cost than a single large die. The second is exactly what you're saying. If I'm building a diverse range of products, then by migrating my product line to a chiplet architecture, I can produce more SKUs at lower cost and produce more differentiated products. The third is, we have two companies that are producing sort of reference architectures, reference hubs. And the question is, if you're a newco, can you make a case that your first generation product should be based on this hub rather than building the entire product on your own? Those are three distinct questions, as at least in my head, and I was sort of going towards let's answer the third one because we have two companies who are fairly active in the two companies who are fairly active in the ODSA, producing these hubs of which people can hang their chiplets. Where it'll be somebody like Anu's company, Microchip, which have to revamp a chunk of their product line towards chiplets.
So yeah, I tried to capture that here with the, like, now thinking specifically about cost. Like, I think ultimately when we think about monolithic versus system solution, maybe one way to go about it is to say, like, just looking at the deltas, what makes your return of investment better and what makes it worse? And to summarize what I had heard and would be the faster time to market, meaning you can sell things earlier, that plays in your benefit. The yield is certainly benefit, but we don't want to necessarily look at this right now because we're talking about chips that would be smaller. And then the modularity is another thing that I would bring up, but again, like, it wouldn't apply to your first product going where you want to go with a hub rather than your own solution. And then the disadvantage would be the packaging cost and other overheads, like larger die area if you combine all the silicon together because of the die-to-die interfaces and so on. Is that a fair summary?
Wait, say that last part again.
The disadvantages or the other overheads?
Other overhead, yeah. Well, sorry, at least, but these are the technicals. I'm saying there are three different business cases. One is if you're building super large chips. The two is if you are a large company revamping your product line. And three is if you're a small company trying to put a product out. These are the three distinct business use cases in my head.
Yeah, and so then like ordering them by what you said, it would be like that's number one, yield, number two, modularity, which only applies to big companies if you can internally reuse. And number three, I guess the only advantage for a smaller company would be primarily the faster time to market and leveraging other work, I guess.
And presumably lower development costs, right? You're developing a much smaller piece of silicon versus something with fewer moving parts.
Yes. Okay, yeah, that's fair.
You're developing some key piece of IP that you like, and then you're buying everything else as hard IP instead of soft IP.
Yeah.
So you're transferring, right? I mean, that to me is like you presumably means a smaller team, smaller everything.
Right. So I mean, like, to me, it comes down to a fairly easy equation that, like, and formulating that equation isn't, at least at the highest level, isn't that complicated. It's then more getting the numbers to plug into the equation to make your decision if you're saving money or not.
Or and then the item number 3 kind of feeds into item number 2 in a sense that if even a small company can sort of say, oh, here's a case, maybe then it's much easier for a big company to sort of invent their own chiplet hub and say, okay, we've got this hub structure and we can sort of make a case for our own internal hub.
Yeah.
And products around that hub, which gets back to Arena's point, I think.
Yeah. So I'm just going to copy in here this thing that I had in the document from last time and maybe just walk through that because I think and it shouldn't be like, it's not rocket science, but just like what I'm trying to think of when I would have to make a decision. So coming to this, like, return of investment, which should be basically all the money that you've earned selling your things, which is your sales price, your average sales price times the lifetime units that you've sold, divided by the money that you've spent developing, the non-recurrable engineering expense, or plus the bill of materials of each unit times the number of units that you've sold. And so to me, the like trade-off that I can see is that you have a higher bill of materials, but a lower NRE cost. So that's one. And then the other thing I guess that I could add is how do you put into dollar terms the opportunity cost, like being to market 1 year early.
Yes. And but can you really prove? I mean, is there any evidence anywhere that developing a simpler IC takes fewer people and time than developing a complex IC? I feel like microchip is the king of answering that question.
Yeah, we should have enough internal data for that. Question is how much of it I can share, right?
Yeah.
But in sort of a loose sense, hopefully you can give us some top level guidance, right?
Yeah, no, absolutely. It makes a difference. We have seen it, and especially if you want to silicon proof certain complex pieces of IP, it takes many cycles.
So Bapi, are you asking particularly even, I think that a smaller chip is less costly to develop is somewhat intuitive, but are you asking if it on top of that scales roughly linearly with complexity or even super linearly? Like basically effectively developing a solution into two halves, even if you combine, even if you had to develop both chiplets, that you would spend less cost developing both of these compared to the whole thing? Is that your question?
Roughly. That
Okay.
in that, you know, you're developing just the accelerator part versus accelerator plus PCIe plus CPU plus
Right.
memory plus you know, all the IO.
Yeah.
Right, and then presumably the second part is your debugging is going to be easier as well. You bring up post silicon number of spins, amount of debug. That there should be some data somewhere that we should be able to at least tap into. Chip size versus develop. I wonder, like, chip size.
I started Googling this and couldn't find much, but I mean, it's certainly like a good question.
Would one of those analyst companies have data like this?
How is that? But that's probably how is that kind of managed? If you find analyst data, you probably still wouldn't be able to share it in a forum like this, right?
Yeah, probably.
Yeah, but should we actually document the 3 business cases of PAPI, which has proposed 4.A, like 1A?
Yeah. So I think we started like that would be like last week the discussion came up about how much are we just building something that teaches the broader audience about the state of the matter in general, and how much do we try to work out things that just haven't been answered well yet. And I think I was also leaning more towards summarizing information that is available and kind of generating a blueprint for each of these cases. But I think, at least from what I heard, the tendency was to say, well, if everything we do is purely academic in a way and just reciting papers and basically pulling together information that's already out there, then that by itself is helpful, but not necessarily what this group wanted to achieve initially. But others feel free to chime in on like that kind of discussion or that the tendency.
Yeah, I think so. I can only tell my personal opinion. So my personal opinion would be that it would be good to start with something which is already available as information, because I have been having some discussions with senior semiconductor stakeholders lately, and the chiplet advantages, disadvantages is not something everybody is completely aware of. And as I mentioned previously in the overview, also, if you say, for example, I don't know, AMD can save costs with chiplets, or AMD can save power with chiplets. This is something a lot of stakeholders would like to discuss about and understand more about this. So understand the background, for example, how do you reduce power with chiplets? And I think that we should definitely also summarize things which are available before we start into, you know, like new areas.
Okay. What do others think? Anyone have a strong opinion, or do you go either way?
No, so Marek, I think I missed part of what Irina said. What was your suggestion, Irina? Sorry about that.
So my suggestion was that we start summarizing of what is already available. So first summarize what is available. Yeah.
I see. Yeah, I suppose. I mean, that's already available information, so that's fine with me. If that's the best way to get this started off.
Okay.
Mark, I have a question here. This is Rajesh. So actually, based on listening to the conversation, I had a question to Anu. Is that the reason that you are saying that the unit cost, including silicon package and assembly cost, for your company or your products, the monolithic comes out winning instead of chiplet? Is that what you are suggesting?
No, I'm not suggesting any one clear answer, right? I'm saying that if you just think about it logically, unless your die size is unless you're in 3 nanometer and your die size is somewhat significant, you're not going to see as much silicon cost savings as somebody like Intel or AMD or NVIDIA, whose die sizes are gigantic.
Okay.
In 3 nanometer, yeah. So that's all I'm saying, Rajesh. I'm not giving any kind of.
No, I thought you were saying particularly for microchip or something, because when Bapi made these 3 important points, that makes excellent sense. Because I thought your business did not fall into those 3 categories, not a startup or big company trying to divert into chiplet, or the first one, like big die sizes. So I thought it was small or microcontroller or something like that. Die size may be smaller. Then it makes sense.
Yeah, microchip is a lot of different products. So
Okay.
yes, it doesn't fit into every one of our product categories, of course.
Okay.
But there is value, as I see it.
So thanks, Poppy, for posting that article. I certainly believe the complexity going up, and I didn't, like, just scrolling through it quickly, I didn't see any graph that says complexity versus cost, which would be more of what we're interested in. And then the other question to me is, if you take a complex system and you break it up into chiplets, do you actually, like, my understanding was that breaking up a complex system into chiplets, each individual chiplet will be cheaper to develop than the whole system, kind of like almost obviously, but that even the overhead of trying to keep those chiplets somewhat general, at least for the purpose that they are designed for, and now, like, co-simulating all of that is by itself going to be more even than the whole monolithic effort itself. So I think I personally would probably say it's not, you don't save with chiplets unless the second chiplet that you use has been built by somebody else and paid for by somebody else.
Yeah, I think that this is probably not what people are doing, because at least according to the documentation which I have read, it's more about, for example, reuse than breakdown, and about reuse from one generation to the other and reuse from one product to the other, which means that you do not break down a system. You have like standard pieces of logic, and if you design your system, you think about using or reusing those standard pieces of logic for your new system. And then you save money because you save development costs for this new standard piece of logic. And you can also physically reuse, like the tooling, etc., etc. So you can just take something from the production line and integrate this into your new system.
Right. Yeah, that makes sense. I mean, that's kind of this modularity idea.
But Irina, the the AMD guys kind of shot down that theory too, right? Because they redesigned all of their chiplets from generation to generation, and a chiplet in one generation is not interoperable in a chiplet from the next generation. There was a packaging guy who gave.
I found some reuse with AMD specifically. So in this article which I read, they have, so if you give me some time, I can tell you in which system they have reuse with chiplets. So yes, it can be that they now have introduced a new generation of chiplets, but in the meantime, they have reduced the existing chiplets a couple of times.
Yeah, so in one generation, they seem to get a lot of product SKUs by going to a chiplet-based design. But they, at least because they seem to be moving packaging technologies and die-to-die interface from generation to generation, they don't do reuse across generations.
So in this one example I had, they did a reuse across generations, but
Okay,
I don't find
good.
it. Yeah, I need to find this, but I don't find it right now.
Okay, no worries, because I was going off there was some packaging guy from AMD. I forgot his name, but maybe I know you remember. You remember he showed up in the Friday meeting. I'm trying to find his name.
Yes, I remember the guy, but
Yeah,
of course I can't remember the name.
He introduced him.
I might have it in my notes. Let me see.
I'm just trying to write this out in the meantime, the difference between the monolithic and the chiplet case, just to have a documented version.
The link I sent does make two cases. One is it at least without any formula, it just asserts that complexity goes up, has gone up in modern chips. And the second point it makes is that a lot of the respins come from the analog part and not from the digital part. And at least with chiplets, you can sort of say you have a crack at both of them. The complexity of the chiplet you're developing is going to be far less than the complexity of the packages, all the components. And presumably most people aren't going to be developing the analog part. They're going to be developing just the digital accelerator. Hemant, that's the guy.
Yeah, Bapi, what were you looking for in the AMD? Because I have some notes from that meeting. What exactly were you looking to say he said?
In fact, I remember asking this question. There's no reuse across generations was his thing that he said. Like pretty much what the packaging in one generation is completely incompatible with the packaging in the next generation.
Well, so I think there's two ways to look at this, right? One is they're really looking for a modular approach.
Correct.
Which
right.
may be what Irina is pointing out, that they want to build, tailored products for a market, but by mixing and matching their chiplets. So if you have a set of chiplets, then you mix and match and you package it for that specific application. I think that's a reuse approach too, right?
It is. So but maybe I'll call that, I like the name that there's a distinction between there's a difference between modular and I guess it's internal modularity versus external modularity seems to be the difference.
Yes.
Modularity.
Wait, what do you mean? This is way above my small little head. What do you mean, Bapi?
Well, let's say you take Dreambig, right? They're sort of trying to make a modular part that the world accepts as an important module, but AMD could just slice their into pieces that make sense to them. They don't have to make sense for the world.
Yeah, they don't give a crap for what Dreambig's doing. What they're saying here is, I can build 10 chiplets and I can mix and match and I can tailor my solution for a specific application by reusing those same chiplets. So it's all internal, yeah. Okay, understood.
But their definition of what makes a chiplet module is entirely driven by whatever they need. It's not necessarily driven by, okay, I need to have a functionality that the world recognizes.
Right, but I think now there's like John said, right, they're opening up their ecosystem for others to plug into.
Right.
But probably also under their terms and rather to fill a position that they don't see enough value developing themselves.
Right.
Yeah, internal modularity is overall like I'm developing a family of products, and what is the cheapest way to service and create for the whole family. External modularity is I want to develop at least one chip. Is there anybody else who can help me get there more quickly?
Mhm.
Right? I mean, that's the distinction in my head.
Correct. I agree.
Yeah, and I think for now we're looking at that external modularity as the thing that we want to tackle first, and then we would go to internal, and then we would go to, I guess, the market, like even more like market dynamics.
Yeah, and can external modularity make the case for internal modularity for those who
Yeah,
but especially because we are two platforms, two guys showing up with platforms saying, hey, here's our platform.
right. So I think when we like what we discussed before about the deltas in cost and why going with a hub may basically save you money overall that you express in time to market and other things. To me, one big question mark is the opportunity cost. And I looked up online how you could specify that, and I think the two things that came to mind for me is like basically one person or like what a couple of articles said you just measure it as if you just assume you sold it a year early, like basically the money that you could have earned in that year if you had it 1 year early, how much would that be? So that I guess is like for everyone that has a marketing department, and I assume for most companies there are like projections of sales volume over a year, and there is inflation, all these things are factored in. So I think that's a number that people could reasonably get, and you could so you could use that cost or that delta as one big chunk of money that you gain using chiplets. And then the other dynamic that's a little bit harder to quantify is this idea, I think, that sometimes there's a notion that the first person to enter a new market gets additional benefits like branding and basically may be harder to displace because they have been the first one to offer a solution. And that's basically an additional delta of if you're faster, you can basically get more market share than you could have gotten otherwise.
Marek, we should be able to punt on this question, right? I mean, if we can demonstrate that you can come ahead a year ahead, we can bring in sort of more business people and say, hey, help us make this case. But we're in this question of, can we really make this case that go with the platform and you will be X months and this many dollars and this many months ahead?
Yeah.
That's it. Yeah, I mean, at least that for that we have the experience on this call to at least take a crack at answering that question. How many months ahead can you come?
To me, that is just at least from the little bit of exposure that I've gotten internally, there are just people whose job it is to estimate volumes at a given moment in time, given competitions, pricing, and so on. So again, that is very much down to specific example to get numbers. Like otherwise, you could just say, kind of generically, look at how much you would sell over the period of time that you think you can accelerate, and count that all as additional money that you otherwise, or that minus, I guess, the money that you needed to build your units. But I think as an idea, that's already pretty clear. I don't know what somebody else could tell us about that.
I'm saying we don't have to pen a number to that. We just have to at least make the first case that you can actually do things more quickly.
Yes, I think that by itself, I would say is or that's more or less our assumption in this whole case. Like we're saying, if you have chiplets, you can do it faster, and we don't know if that's true, but we're just saying it very likely will be, right? And we're just picking a number how much faster you think you'll be.
But that's in my mind, that's what we should take a crack at, to sort of say, okay, here's here's an ASIC development for an accelerator this many months, and here's with, let's say we take Dreambigs or Apex's framework, and this is the before and after in our opinion.
Okay, and then you would ask them for their estimates based on what they're using internally to demonstrate value to their customers.
And I think we should generate that, right? I mean, we know roughly what their hub is. They've described it, and they said, hey, our hub has these features and these things, and these are the chiplets that we know exist, and
Okay.
we should be able to take a crack at that ourselves, in my mind, as a group.
Okay, and like so I personally wouldn't know. I mean, I could try to go to IP vendors, say like, tell me how much this IP would cost, and basically build that up myself. But I wouldn't know how to estimate and say like, okay, I see this hub. To me, that's I don't know, like $60 million development, and it would have like taken a year and a half or so. You know, like I feel like I would just be guessing.
We don't have to estimate the hub's development cost. We're like, so there are two dev paths. Let's say I'm Nuco X trying to make a inference engine.
Mm-hmm.
My choice is make just the inference engine, attach it to the hub attach it to the hub and get a Ventana CPU and use their memory interface.
Yep.
Or buy CPU IP, but get a DDR IP, get PCIe IP, get and glue it all into one chip on my own. Those are the two choices, and we don't need to know anything about the hub's development costs.
Okay.
Anything at all.
But then we need somebody else to give us to like, either you keep it generic enough and then you can choose any number, or you go in a very specific detail and clearly define what you're comparing to build. And at that point, like, either we take a straw man like approach, I guess we could do that and look for like we won't be able to discuss quotes on like DDR4 IP in the call, I think.
No, but we don't. Well, I feel like you can ballpark them, and I mean, like,
Okay.
we should be able to ballpark it. Like, people may not give us exact numbers, but we should be able to sort of, to a first rough order of magnitude, we should be there. And might be off by, 20%, 30%, but
Okay, so you're proposing, let's just together come up with like a definition of some kind of system that is just like, that is not necessarily tied to a specific business case, but we would just say in general, we think that would be something people would want to build for some application, and just plug in the numbers and say, if we just build our accelerator function, we pay this much. If we had to build the whole system, including all the IO parts, we would spend this much.
yeah. In fact, I would even go one deeper. I'd say let's take Meta's 30-watt AI inference engine that they rolled out yesterday.
Okay, I mean, if you have information on that, then
whatever the
please,
public
share
information is,
that.
work our way backwards from there. Here, that they rolled
Okay.
out yesterday, and say, okay, suppose I just built a neural network part and attached it to a dream big like hub. What would it be versus what they're saying?
Okay, sure. I mean, that would work for me.
And or if we attach it to a Fraunhofer like hub and say, okay, can you make the case that this is the cost of X versus the cost of Y?
Yeah. Okay.
It is, that's like, just to be clear, that's just my proposal. I'm not like interested in pushing everybody in that direction if you don't agree. Let me put it that way. But
yeah, no, it's helpful to have at least ideas being proposed. I think the benefit of this is that it's very clear, because we like know exactly what we're comparing. But then a couple of calls back, the question of garbage in, garbage out. Like, if we basically go in with 20-30% uncertainty on the prices, then if the savings comes down to, say, 10%, then how can we be confident that it's a good decision to go with chiplets if we know that our deltas on the input can totally flip the solution?
Oh, again, it's a no-brainer. Chiplets are a non-starter. If the best we can do after all the huffing and puffing is 10%, chiplets have a major problem on their hands, at least for this use case.
Yeah. Okay. So and even then, we basically even finding this number of the numbers we have versus like even finding determining the uncertainty and being certain about the uncertainty is like, I think all of this would be easy if again one company did that and said, okay, I want to build exactly what they built, and they just get all the actual numbers, because also these things change depending on what kind of player you are in the market, like what kind of conditions you would get for IP and wafers and so on.
I think we can get help from Meta in 3 months, 6 months. I believe if we go to them and say, this is what we're trying to do, we are doing it in my thought exercise, we should be able to get information from there about their AI accelerator, non-proprietary stuff.
Okay.
I believe so.
Okay. What do other people think about, like, about this proposal or other ideas?
Yeah, I think we've got to start somewhere. And so, going with Bapi's idea of taking Meta's newest release and saying if it's a standalone chiplet and then plug into the Dreambig's IO hub, versus if it was an accelerator with its own IOs, its own entire system. What is the cost differential to build that SoC versus practically a pluggable instance of an accelerator? That's a start. It's a use case.
Okay, I mean, I'm happy to do something specific. I think we've been going around in circles for long enough.
Agree. Yeah.
So, anyone else endorsing or criticizing this proposal that hasn't spoken up?
No one dares to mess around with Bapi. That's the problem.
Yeah, nice.
Yeah, I mean, we definitely have the authority here on our.
Yeah, we just agree. We're like, yes, boss, we got it.
Sure.
Okay, I mean, I think then I would be happy to do that next time. Bapi, do you think you could send me the information, like on just kind of a link that I can put this into the notes for today already? And I would start with a little bit of prep work, just kind of like putting this into some way to present it, and then we can talk about, like, actually on a specific use case what we would do. And maybe I'll also reach out to Suresh and ask him to talk a little bit more specifically about the features of their platform, so that we can go into detail of what that would look like.
Yeah, so maybe what we can do is I'll dig up the public presentation. Next week, we chase down Ravi and DJ and ask them if one of them can be in this meeting next week.
Okay.
And we bring Suresh in and see if Andy can make it. I mean, for him, it's like 7 p.m. on a Friday, which is hardly the most exciting time to be at work.
Yeah.
But if we bring them in and say, this is what we want to do, and see what their gut reaction is, whether they say, look, we want to sort of cross-check our assumptions against the accelerator inference engine you guys have built. Because that thing comes with a variety of descriptions. It says it's in this process node with this, roughly it dissipates this much power. I think they said something between 25 and 30 watts yesterday.
Okay.
So there's a whole bunch of public information which we can use as a starting point in my head.
Okay, yeah, no, that sounds good. So reaching out to Ravi and who else did you say?
DJ.
Ravi and DJ. Okay.
And then
tomorrow's like next Friday is also the Friday before Memorial weekend.
Oh, maybe, yeah. Actually, I wasn't going to do a meeting next week, so maybe the week after.
Okay, so then we do it the week after, maybe. Yeah. Okay.
Hey, I know if we can get this some sense of size versus even to a first order. Like you're developing a smaller block, so it's going to take a less effort.
Yeah.
And fasterly, as it were.
Yeah, let me try. Let me see what I can get ballpark or approximations without hurting feelings here. So.
Okay, thank you.
Hey, and Marek, I will not be there for the Friday after next. Got some family obligations and
gotcha. Okay.
Parent stuff to take care of. So.
Okay, no, that's fine. Thanks for the heads up.
Yeah.
Okay, I'll stop the recording here.